Hi everyone, Jane from Lavender Learning here. Thanks for tuning in today to learn about prime and composite numbers. Let's get started. Okay, before we use the terms prime and composite, I just want to explain what I mean when I use the term factor as well. So a factor is a number that divides into another number exactly without leaving any remainders. I'm going to demonstrate that here on the screen. You can see that I've broken up my dice face that has the 6 dots on it, and I've broken it up in different ways. And all of those options have groups of dots without any left over, without any left out. It's divided nice and neatly. Okay, so in the orange circles, you can see on the screen there, around the first of the groups of 6 there, the first dice face, you can see I've circled 6 little groups of 1. Each individual dot has an orange circle around it, and each dot is in its own circle. No dots are left out. I could break 6 up into groups of 1. So that means that 1 is a factor of 6. It means that I can break 6 up by 1s and there'll be none left over. Okay, then we're going to look at the one next to the orange circles, the one that has the big pink ovals on it. And you'll see that I have put one of those circles around 3 dots and the other one around another 3 dots. There are no dots left out on the face. All 6 dots are included in 2 groups of 3. So that means that 3 is also a factor of 6 because I can break 6 into groups of 3 and none are left over. If you look at the bottom right there, I've put a big green circle around all 6 dots because one group of 6 is a way of grouping those dots together so that none are left out, which means that 6 is a factor of 6. And then finally, you can see in the bottom right there, I've used a blue coloured pen and I've gone around a group of 2, another group of 2, and another group of 2, 3 groups of 2. And that tells me, since none are left out, that 2 is also a factor of 6. So I can break the number 6 up into groups of 1 and groups of 6, 6 groups of 1 or 1 group of 6. I can also break it up into groups of 2 and 3. I can have 3 groups of 2 or 2 groups of 3. And that means that this number has those 4 different factors. Okay, so now you know what a factor is. It means can we divide the number up neatly with none left over by another number. Let's have a look now at prime numbers. Okay, so prime numbers are numbers which only have 2 factors in total. So think back to factors that we just talked about. Prime numbers only have 2 factors, and those 2 factors are the number itself. So if I have 5 lollies, I can put them all together in one group of 5. And that would be a factor of 5, or the number 1. In other words, I can split my 5 lollies into 5 individual groups of 1, and that 1 would be a factor. So every number has the factor of 1, where I can break it up into groups of 1, or the number itself, okay? But some numbers only have those 2 factors. And that is a prime number. That's what the word prime means when we talk about that in maths. For example, I put 3 dots on the screen that you can see in front of you there. And then I showed you in orange how I could make 3 groups of 1, breaking that number up, or how I could make, in green, 1 group of 3. Those are the only 2 ways I can break that group of 3 dots up. If I try and split the group in half, I end up with 2 on one side and 1 on the other. They're not the same. And remember, for a number to be a factor, it has to be evenly grouped with none left over. So that doesn't work if I try and split 3 in half. Composite numbers then are numbers which have more than 2 factors. So composite numbers are numbers which are not prime. So basically, if you have more than 2 factors, the number is prime, except for the number 1, which is generally said to be neither prime nor composite, because 1 only has 1 factor and it's 1. And because it itself is 1 as well, it still only has that 1 factor. So take out 1, then every other number is prime or composite. If it only has two factors, one in itself, it's prime. And if you can find other factors, a number can be divided into equal groups of 2 or 3 or 4 or 5 and so on, then that number is composite. The number 6 that we looked at earlier, remember that I could break that 6 up into groups of 1, one group of 6, 2 groups of 3 or 3 groups of 2. So it had 4 factors, which means it would be a composite number. Okay, just going to move my face over so we can have a look at some numbers. Let's see. I want you to pause the video in a moment and write down these numbers: 18, 23, 27, and 51. And then I want you to try and work out how you can break these numbers up into equal groups. In other words, what the factors of these numbers might be. And I want you to see whether you think they are prime or composite. So pause the video now, come back and press play once you've made a decision about whether you think each number is prime or composite. Okay, hope you had a go and you've come back to find the answers. So 18, well, I can divide 18, and I use the word on the screen divisible by. It just means the number can be equally divided into groups of 1, groups of 18, so 1 and the number itself, but also it's an even number, so it can be broken into groups of 2, 2 groups of 9 or 9 groups of 2, so 9 is another factor. It can also be divided equally into 3s and 6s, 3 groups of 6 or 6 groups of 3. So that means that the number 18 has quite a lot of factors. It's got 1, 18, 2, 9, 3, and 6, definitely a composite number. 23 can only be divided by 1 and 23, 2 factors, 1 and 23. And we know when the number only has those 2 factors, 1 and the number itself, that means it's prime. Number 27, you can divide that one by 1, 27, but also 3 and 9. Now, sometimes we have this feeling like an odd number is probably going to be prime, but it's important to think about that and check. 27 is divisible by other numbers as well. It has 4 factors, so it's a composite number. And finally, 51, another one that feels like it should be prime, actually has 1, 51, 3, and 17 as its factors. I can divide 51 equally into 3 groups of 17 with none left over. So that means that that number is also composite. Now, even numbers after 2, so 2 you can only split up as 1 group of 2 or 2 groups of 1, which is the definition of a prime number. The number and itself are the only factors just for the number 2. But after that, every other even number, 4, 6, 8, 10, so on and so on and so on, forever, those numbers are all composite because they can all be divided equally in half because they're even numbers, okay? So all even numbers above 2 are going to be composite. And as I said before, does that mean that all odd numbers are prime? Definitely not. You need to check every number. Now here's a little tip for you. You can find a printout. I sell a Divisibility Rules resource on my TPT store, but other people have them available for download on the internet. You can find a good little poster or something to stick in your maths book to help you remember some of these really easy divisibility rules. So you can see there that there are tricks that you can use to check if a number is divisible by another factor. I know, and I use this one a lot, that if all the digits in a number add up to a number which can then be divided by 3. So for example, with 51 that we talked about on the last slide, or 2 slides ago, 51 is 5 plus 1. If I add those 2 digits together, 5 and 1, that gives me 6. 6 is divisible by 3. So I know that that whole number is going to be divisible by 3. And that divisibility rule is on the screen here right now. If the sum of the digits, or if you add the numbers in the numeral together, you will end up being able to divide the number by 3, or you won't. And if you can divide it by 3, the whole number is divisible by 3. And if you can't, then it's not. So you can have a look there at all of those rules. And as I said, Google it and find a printout that you can stick in your book to help you. Okay, now here's something different. Just going to move my face again. If you're getting up into upper primary school or lower high school, you might find that you're starting to work on factor trees. And all a factor tree is a way of breaking all of our numbers down eventually to prime factors at the bottom of each branch. So I like these kind of models where the composite numbers are in rectangles or squares and the prime numbers are in circles. I feel like it's quite a helpful visual guide, but not all factor tree templates will have that. But for example, for the number 48, we can break that into two factors. There's lots of different ways you can break up 48. 1 times 48, 2 times 24, and so on and so on. It's got lots of factors. But the ones that have been chosen in this example are 6 and 8. 6 times 8, or 8 groups of 6, they together make the number 48. So I'm going to split it into those two factors first. Then each of those factors can be broken up a little bit more because neither 6 nor 8 are prime numbers. They're both even and they both have other numbers that can be broken into, because 6 can be broken into 3s evenly and 8 can be broken into 2 4s evenly as well. So if I break down 6 into 2 3s, then I've got my 2 and my 3 at the bottom in circles because they are the final prime factors. I can't go any lower. Those two are prime numbers. If we come over to 8, 8 can actually be broken up into a prime number, but another composite number as well. So 2 times 4 will give us 8, but 4 isn't a prime number because 4 can be made up of 1 times 4, 4 times 1, but also 2 times 2. So we have to break this number down even further to get it to its prime factors. So we've come down to 2 times 2. And right at the bottom then, our prime factors are 3 times 2 times 2 times 2 times 2. Let's have a practice. I want you to pause the screen now, copy this down, make sure you make a note of the rectangles and the circles. The rectangles are for composite numbers, the circles are for prime numbers. See if you can work out how to break down 54 in a factor tree. And then when you're ready, come back, press play, and we'll go on to the next slide. Okay, so here's how I solved this one. I knew that at the top here, I had to have a prime number. So I had to divide 54 by 2 or 3, not 1 because I couldn't have just 1 and 54. But here, this one here, I looked at the fact that it's an even number and decided to divide it by 2. Okay? 5 plus 4 is 9, which is also divisible by 3. So possibly I could have tried 3 here and then a different number here, but I decided to go with an equal split to start off with and leave this branch right here. 2, and it's 2 times 27, which gives me 54. 27 is a composite number because it's 3 times 9. So then I broke that down even further, put my 3 here because that's a prime number, and I put the 9 in the composite box because 9 isn't a prime number. 9 can be broken into 1s, 9s, and also 3s. So then I had to break down this composite number one more time down to 3. So the prime factors on this tree are 2, 3, 3, and 3. Sometimes you might be asked to write that out like this. So you look at all the prime numbers, I've highlighted them here for you, and then write them like this: 2 times 3 times 3 times 3 equals 54. And if you actually work that out, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. Another way that you might be asked to write that is to group the like numbers, and I've got 3 times 3 times 3, which can be written like this: 3 cubed. 3 times 3 is 9 times 3 is 27. And then I've got 2 times 3 cubed, which is 27, which is the same as this. That's a bit more complicated for older kids, but that is another way that you can write that then. Nice and simplified right down to its prime factors. 2 times 3 cubed equals 54. Just to go back here for a minute, this is the sort of level that you might see around grade 6. here in Australia. And this is something you might see in grade 7, 7, 8. Okay, just to give you an idea, if you're feeling a bit confused because you came here to learn about prime and composite numbers and you're wondering if you should know this information as well, you don't need to worry about factor trees unless you're at the upper end of your primary school or the lower part of your middle school journey. Okay, if you're here just to learn about prime and composite numbers, all you need to know is whether a number can be broken into more factors than just one and the number itself. And then also, if you can have a look at those divisibility rules, they'll really help you, give you a bit of a secret superpower as well. Okay, if you have any questions about what I've covered in this video today, please comment below and I will try to respond to those questions as soon as possible. Don't forget also to like the video, subscribe to the channel, hit the notifications bell so you're notified when I put up other videos, because I'm sure there'll be topics that will come up that will be helpful to you as well.